Hello, and welcome to our conversation about predation. So we hear about predators and prey and all of these things, but what we really want to do is talk about how predation works, what exactly does it mean, and why is it so important, okay? So for starters, though, let's look at this picture right here, okay? So you see here a cobra, which is a lovely little snake, and you have here a little mongoose, which is a cute little mammal. And so my question to you about this picture is, which animal is the predator? Well, we know that snakes eat all kinds of little mammals. They eat rats and all kinds of stuff. And then actually they eat all kinds of things when it comes right down to it. And they are predators. They are carnivores. But in this case, it's actually the mongoose. The mongoose is a snake eater, right? And as a matter of fact, they are expert cobra killers. So this picture I think is really fun because you look at it, you don't really know who's the predator, but it turns out that it is the mongoose. Now both of these animals are predator. But in this picture, the mongoose is the predator and the cobra is the prey. Okay, so what exactly is predation? This is simply where one organism feeds on another. And so that means that any organism, any consumer that feeds on something else is actually a predator. So cows are grass predators, wolves are elk and caribou, deer, whatever predators. So when we talk about predation, though, as we're talking about this class, we are typically going to talk about active predators. Although it is going to apply to anything that eats anything else. Okay, so let's talk about some various strategies. How do you catch prey? How do you not be prey, right? So first thing I want to talk about are all the structural advantages, and we're going to start with the natural weapons, the things that you think of when you think about, I'm a predator. And this is the paw of a cougar. You can also call them mountain lions, pumas, catamounts, Florida panther, right? Those are all the same, but those are giant claws. Yeah, those are for grabbing and tearing. Teeth are helpful, right? Beautiful weapons. Nice hooked tearing beak, giant clasping claws. These are all going to be things that you see in predators. However, right, let's not count out little pokey horns or teeth for biting or claws. Now these claws are actually made for digging, but they work, right, in a pinch to help defend against a predator. So all of these things, although they have other purposes, can be used as natural weapon for the prey. Another really big thing would be flexibility. It is helpful to be super flexible. Here you can wrap around your prey, crush it. That would be a predator. But if you are prey, it's very helpful to be able to blend into the rock right here, or even get into one of those tiny spaces, right? Now, in this case, you're looking at an octopus, and they are both predator and prey, and they employ this strategy both as predator and prey. Lures, right? That little tail right there looks a little bit like an earthworm, right? This snake will wiggle this, and so it will attract things that eat earthworms, and then it will eat them. This is the super famous deep water anglerfish, and you can see that it has a lure. Now, there are lots of different kinds of anglerfish. This is a female, by the way. They are all the big ones. This one lights up, which I think is really cool, but they can have little like fish or seaweed looking things, and they'll actually wave this around so they can attract prey. Obviously, you are a predator if you have a lure. Okay, now, if you're thinking about arming up, plates work quite well. You can see these three are invertebrates. These guys both have carapaces that are hard. They are exoskeletons, but those make great defenses. Here you have an armadillo. It's covered in little plates, and here of course you have a shell, which is very helpful. These are going to be prey. Obviously, if you're not going to be eaten, you probably don't need armor. Another form of armor would be spines, right? So here you have a caterpillar, and these are real fun because these are actually poisonous too. The cactus, nobody wants to mess with that, and you certainly don't want to get a snout full of the tail end of a porcupine. So these would also be prey animals. If you get caught, it would be very helpful if you have a breakaway part. And probably the one we're most familiar with are lizards. Lots and lots of lizards' tails just pop right off. But flying squirrels also have tails that pop right off. This would be helpful if a predator captures you. You can just run off, leaving your tail behind. Now, one of the other things you might want to consider is size. Size can be a huge advantage. Maybe you would like to be big enough to eat everything. if you are a predator. If you are prey, perhaps you would like to be too big to be eaten. But what if you're not so big? You can puff up, right? Inflation helps with your size. And what's super fun is if you inflate and have spines. So as we go through, you're going to see that there are lots of animals that employ multiple strategies. Okay, so these guys are all prey. Now, what about hiding? Yeah, if you can blend into your surroundings, it is much harder to be detected, right? Obviously, some can't. But here we go. We're going to look at this picture. In this picture, there is a prey animal. Can you see where it is? There is a rabbit who blends quite well into the background there, and this is called cryptic coloration, better known as camouflage. And both predator and prey are going to actually, both predator and prey are going to employ this strategy. And just because you are brightly colored doesn't mean that you're sending a message. In some case, bright colors mean that you actually are camouflaged against something that's brightly colored. And then here you have some other guys that are also going to be both predator and prey, although these guys are both apex predators. And so we think about the tiger with those orange and black stripes, but remember where the tiger lives is a forest that's got dappled sunlight and various types of leaf coloration. And so when this tiger walks back into this forest, she will be camouflaged just like these lionesses here. Okay, now, not just about having one color if you live in a place that has different habitats at different times. Seasonal color is very helpful. So these guys in the summer would want to blend in, and in the winter they would still want to blend in. Now, side note, this is an Arctic fox, and this is the seasonal coloration of the Arctic fox. For summer, this is the Arctic fox. In winter, you can see it's got thinner hair here, fluffy here. On the other hand, these are not the same rabbit. This is actually a jackrabbit, right? And you can see these giant ears tell you that it lives someplace really warm. But I couldn't find a really good picture of this cutie snowshoe hare right here with its normal seasonal color. So you're getting a picture of two different animals. So I just want you to know, those are not the same species, but the snowshoe hare does have this kind of mottled brown coloration in the summer, but not the same species. Okay, now it turns out that colder climates tend to have lighter, muter pigments, while tropical animals have darker, brighter colors, and this is Gloger's rule. And it turns out that we think that dark pigments are really more resistant to breakdown by bacteria, and bacteria tend to thrive in warmer environments. And so you can see here you've got so it's a combination of two things. Even when you have a nice, like, snowy environment, you're going to want to be white. But here you have various colorations of brown bears, and then you have black bears over here who live farther south than the brown bears, and so you can see they get darker and darker. And then you have your spectacled bear here. One of these is a Malaysian bear and one of these is a spectacled bear, and I can't actually read it, but anyway, but you can see that you actually get darker as you move further south. Okay, something else happens as you move further south and or north, depending. And so this picture also illustrates another rule. I'm going to go ahead and tell you because you probably don't know. This picture also illustrates Bergmann's rule. And Bergmann's rule should have two ends. I will fix that. And you will see that in the regular PowerPoint. Okay, I have now fixed that. You wouldn't know the difference in terms of time, but I fixed it. Okay, so anyway, back to this. Bergmann's rule actually says that animals will get larger as you moved into colder climates. And here are two deer skulls. These are the same species. This is a version in Michigan, and this is a version in Nicaragua, and you can see there's a huge size difference. And it's true for not the same species as well, but bears are relatively new, by the way, and so you get this change. Okay, but back to coloration. Warning coloration, aposematic. I am poisonous or I do not taste good. This is a great prey strategy, okay? What if you can't, so there are different kinds, there are different kinds of aposematic coloration. There's just being yucky, right? You can be bitter or you can smell like death. This is a monarch and a hognose snake. These guys are gross. I mean, they look like they're dead, they smell like they're dead, and that's a really good way to deter predators because nobody wants to eat something that's rotted. Now, you can also spray, right? This is a bombardier beetle who sprays a highly exothermic mixture of chemicals that are stored in its abdomen here that are mixed when it sprays out. And of course, this is your fun friend, the skunk. Now, you'd think to yourself, well, the skunk is black and white, so how is that aposematic coloration? Because aposematic coloration is really bright all of the time. Skunks are nocturnal. What's brighter at night than the stark contrast of black and white? So just because you're not red or yellow doesn't mean that you're not poisonous in some way. Okay, so this is a great prey strategy. You could also just be poisonous, right? You could have really good toxins. And all of these guys have toxins. Lots of plants actually have toxins because that's a really great defense if you're a plant. And I'm going to ask you a question about that in just a second. These, of course, again, are all prey. So this is this, hey, hey, I'm poisonous, don't eat me. So why would plants produce toxins? Toxins are very expensive, right, to produce. So why would a plant bother to do that if it has to also do like reproductive structures like flowers, which are expensive, things like that? So the energy cost is outweighed by the benefit of deterring herbivores. The defense is a secondary benefit since they're actually plant pheromones. These chemicals are not produced, they're assimilated from the soil, or plants do not produce toxins, but some herbivores have allergies to chemicals necessary for plant metabolism. Only one of these statements is actually true. The rest of them are false. And the true one is one. It is worth it to the plant to produce all of these chemicals because it deters herbivores from eating them. And remember that plants have indeterminate growth. So a part of a plant can be eaten and the whole plant still lives, right? And so it's beneficial if you are poisonous or bad tasting because then the herbivore doesn't eat the whole plant. Okay, but what else? What if you're a predator? You can use those same toxins to kill your prey. Yay! And I think we all know what these are. We've got the black widow, we have the rattlesnake, and we have the scorpion. Now, there are behavioral strategies, right, that animals use. And a big one is ambush, right? You can hide and wait. And here is a praying mantis, and they will just sit there really still, and then as soon as the prey comes within striking distance, they will strike. This is a spitting cobra. They will actually spit. Now this is actually more of a defense, by the way, so that's kind of under the spray category, but anyway. This is a cutie little coyote who is about to stalk something and pounce on it. So stalk and pounce, hide and wait. These are predator strategies. What about being fast? Speed and agility, right? And I put the praying mantis here again because they are so fast you cannot actually film the strike. You have to use really special slow motion film to do that. You've got your silent killer, the owl. You have the cheetah, who is the fastest land animal on the planet and is actually quite well suited for running up to 70 miles an hour. And here you have a raptor who is going after birds in a flock. Predators. Well, if you have a fast predator, you probably want to be fast prey. And so agility, typically, right, you'll be both fast and agile. One of those will be better than the other ones. Cheetahs, for instance, are really, really fast. But gazelles, those are the things they eat, are really fast, but they're not as fast as cheetahs. They are, however, more agile, which means they can turn better. And so that gives them a second to get away. All right, now, you can also be really slow. This is a slow loris. Sloths and slow lorises move so slow as to be undetected. Fun side note about the slow loris that you're looking at here. They have venomous saliva that they smear all over their babies, so when they go off to eat, their little toxic babies are sitting there waiting for them to come back. Okay, now, if you are aquatic and you are large, you can use the gape and suck method, and that is just to open your mouth and swim into your prey. This is a whale shark, and this is a whale. So, there you go. Both predator strategies, but it's only aquatic. Now, living in packs is really helpful too. Predators can hunt in packs, right? And so you can ambush and attack all together. Prey, and here you actually have predators and prey. Prey can live in groups. It works for confusion. You really only have to be faster than the guy next to you, so that's kind of exciting too. So it works pretty well. And actually in both these pictures, this is a group of prey, this is a group of predators, this is a group of prey, this is a group of predators. Okay, now large works, small also works if you can cower, right, and get really small and hide, or if you can roll up into a ball. That's pretty exciting too. How about looking fierce? Just because you're a predator doesn't mean that you don't have situations in which you need to chase something off. So raising up and showing your weapons is a really good strategy, right? For prey, But also, sometimes, like I said, just because you're a predator doesn't mean you're not prey too. All right, posturing, and again, I love me some praying mantis. I'm just going to tell you. This picture was actually taken because the photographer and the praying mantis startled each other, and so she's saying, "Look, I'm going to get you with my giant claspers here." Okay, now, what if none of this works for you? There are some animals, like the hognose snake, that play dead. The possum doesn't smell dead, but it looks dead, and it's a pretty good deterrent to dogs and things like that. Okay, now, looking like something else. This is a really good strategy. It's called mimicry. And the type of mimicry that you're most familiar with probably is Batesian mimicry. And in Batesian mimicry, you have something that is poisonous or, toxic or well, those would be the same. But you have something that is not fun. It produces a chemical that is not fun for anyone else. This is a coral snake, right? Red and yellow kill a fellow, right? Remember that? And then this, of course, is a honeybee, also not fun. This is a milk snake, right? Red and black, friend of Jack. This is a robber fly. It is a fly. It is not poisonous at all. And then, of course, back to the monarch. This is the monarch that we already talked about as bitter, right? And this is the viceroy. The viceroy is delicious, yeah, but it looks like a monarch. So if a bird has eaten a monarch, it will not eat the butterfly. Now, the catch is that there might be a large learning curve. You could eat a milk snake several times before running into a coral snake, right? You could eat a robber fly several times before running into a honeybee. So, there's a little bit of a learning curve. However, what if everybody's poisonous and they all look alike? This means anytime you see black and yellow, if you live in this area, it's going to be a bad thing, right? All of these guys will hurt you. And so having this similar color pattern, right? All of these guys taste bad. All of these guys taste bad, and they all look alike. So, well, I mean, there's groups, but you know what I mean. So this has a really fast learning curve. There's no point at which you're going to get a tasty one because they're all bad for you. Okay, Batesian mimicry is more efficient strategy than Mullerian mimicry since no toxins must be produced. True or false? Well, that's actually false, right? Because remember, in Mullerian mimicry, there's a faster learning curve because everybody's toxic. In Batesian, you might get eaten right up until that predator has more experience with the toxic version. So there's a risk there. So that is false. They both work. That's why they happen. All right, now, what if you look like something scary? That is super scary. Ooh, that is scary too. Giant predator eyes. That would be deterring. Ooh, that is super scary. Snake. Also super scary. Caterpillars. It would be harder to eat something if you think it's something that's going to hurt you. Okay? And then you can also, if you're a predator, mimic your prey. Okay? This is the prey. That is the spider. That is the predator. And then this is one of my favorite spiders. This is Portia. And she is a spider killer. And she walks like trapped prey. And so she actually gets on the edge of another spider's net. And she'll do her little crazy wounded prey wiggle walk. Trapped prey wiggle walk. And then the spider will come over and she'll bite him and eat him. I know, right? That's very cool. Okay. You could also look like something that's not alive. You can just hide among all of the inanimate objects. So your job is to figure out there is something alive in this picture, and when you get into class, I want you to ask me if you can't see it. Yeah, but there is something living in this picture. Leaf, mimic, right? And then I love these walking sticks. These are fantastic. They look like sticks. It's very exciting. Now, it doesn't matter, predator prey. This can be helpful either way. If you're an ambusher, this is a really great strategy. Okay. Now, move like something else. What if vision that's great, and coloration, everybody's the same color, but you're still, whatever. Another great strategy is to actually move like something else. And this is the mimic octopus. They live in Indonesia. And on your PowerPoint, this little star here will go to a video that shows all the different kinds of animals these guys mimic. And they're all predators, right? This guy's delicious. The things he mimics is not. They are not. Okay. Now, there's some other types of mimicry that I want to talk about. And the first one is egg mimicry. And this has nothing to do with predation. This is actually a parental care thing, but I want to put it in because we're talking about mimicry, and mimicry just means looking like something else. The big eggs here, right, these, which look very much the same, are not warbler eggs. They are, in fact, cuckoo eggs. And the cuckoo will lay their egg in this nest, and when the cuckoo is born earlier than the other chicks, right, that belong to the actual parents, it will kick out all of the other eggs, so it is the only chick left, and then the parents of the warblers will just raise it. And so the cuckoo doesn't have to raise her young, she doesn't have to put any effort, and they get pretty good care, and they don't have any competition because they kill everybody else. Now, chemical mimicry, this is the other thing. This is an orchid. It will release pheromones, and it kind of looks like an insect, right? But it's a female. It'll release female pheromones. The male comes thinking he's going to mate. He picks up the pollen, and then he goes off to another one. Here's one, yeah? Okay. Then the other one, and I think this is really cool, is aggressive chemical mimicry. So this is a jewel wasp, right? And they release pheromones and all this good stuff that smell, right? And so they attack roaches, cockroaches, and you'll be excited about this if you do not like the cockroach. The jewel wasps will attract the cockroaches, and then they will sting it, and when they sting it, it paralyzes it, but it's still alive. And they lay their eggs in it, and the eggs grow, and they eat the inside of the cockroach out, but the cockroach the whole time is a zombie. What? That's crazy. Okay, moving on to coevolution. Coevolution is where predator and prey shape each other, and so a lot of the things that you see in nature in terms of biodiversity are shaped because of this predator-prey coevolution. The predator benefits from the relationship because it eats the prey. The prey is always harmed, so it's going to develop ways to avoid the predator. The predator has to become better at catching the prey as the prey adapts and evolves and all of this good stuff to avoid. Then the prey has to become even better at avoiding the predator, and so on and so on. And so you get this constant arms race as the best of the predators catch the prey and pass on their genes. The best of the prey pass on their genes and don't get eaten. Now, here's your last question. Large carnivores could only evolve, right, are big, large predators, after grasses, before the Ice Age, in response to competitive pressures, or by random chance. Well, we always talk about mutations being random, right? But as we'll learn in the next unit when we talk about evolution, evolution itself is not actually random, and so that is not the answer. Ice Age doesn't really matter, right? Competitive pressures, they're all competing, and so that's going to shape them because there's a coevolution kind of situation with competition as well. But really, in order to get large carnivores, you have to have large herbivores. In order to get large herbivores, you have to get things they can eat. Typically, they're going to eat grasses. So you don't get really large carnivores until after grasses evolve about 30 million years ago. Okay, now this is just for fun. There are dogs and there are cats, right? There are your caniforms, and these are all of the predatory mammals that fall into the dog category. And then there are your cats, your feliforms. These are all the predators that fall into the cat category. And I just think this is a fun thing. So these are the lineages. These guys are all more closely related than these guys are. All right, and that is it. If you have any questions, please ask me in class, and I will see you next time. Thanks for listening.